Hey viewers, this is VCube here. Today we'll be learning how to graph sum of two functions, more specifically sum of linear and a non-linear function. So let's get started. So to study this, we'll simply examine a graph of f of x equals x plus modulus of x. We'll be discussing two questions in this video. Your first question is x plus modulus of x. So the linear function here given over here is an identity function which is f of x equals x. So the function is going to be f of x equals x for the entire domain, but whereas for modulus function it is not going to be like that. So the reason why, because let me draw the graphs. For y is equal to x, you're going to have something like this. Alright, so this is going to be a y is equal to x graph. Whereas for y equals modulus of x, it is going to be a V-shaped graph. So the reason for this V shape is that the function works differently on different domains, and that is the problem that we are encountering over here. If there were two regular functions, we could have simply added the outputs of the two functions and then graphed the functions. But over here, we are having a function that works differently on different domains. Now, what are we going to do? We'll first write how the function is going to work for different domains, which means we'll have to express the given function in piecewise form. So what we'll do over here is we'll simply write when x is negative and when x is strictly non-negative. So you'll be having, when x is negative, you'll be having minus x, and when x is positive, you'll be having plus x. So the reason why we are having negative x is that when x is negative, minus x becomes positive. So ultimately, the output of the entire modulus function would be positive. Now, what we are going to do with your function x, the identity function, though it need not be written in terms of piecewise function, you'll have to adjust the function in terms of modulus functions domain, such that when you add both the functions, it will be easy, which means you'll have to add the function on its own domain. To add the function on its own domain, you'll have to understand how the domains are separated. And how are we separating these domains? Based on the modulus function, because modulus function is composed of two functions in different domains. So when x is negative, your identity function is going to be x, and when your x is non-negative as well. Now it is easy for us to add these two functions. Your x plus modulus of x would be like, your x and negative x cancels out each other, so it would be 0 when x is negative, and when x is non-negative, the answer would be 2x. So let me draw the graph x and then y. So the function is going to look something like, when x is non-negative, it is going to be 2x. So this is going to be y is equal to 2x. And when x is less than 0, it is going to be 0. So it is going to look something like this. So this is your function. Now we'll work out another problem to deeply understand this concept. So we are asked to graph x plus floor of x, right? So your floor of function, floor of x is simply your greatest integer function. Now, examine the function that needs to be written in piecewise form. So which one is that? Obviously, it is your greatest integer function. And greatest integer function, at least modulus function had only two pieces. But greatest integer function is going to have several pieces, like infinitely many pieces, because the domains are split between each integers. So what we'll do is we'll just write a general notation for your greatest integer function. Your floor of x function always takes the value n whenever your x takes the value between n till n plus 1. For example, if floor of 2.1 is 2, so how we just expressed now is that if your x is between 2 to 3, the value is going to take n, right? So it is going to be 2. It is as simple as that. So that is how we just expressed a floor of x function. Now I'll simply write your x function as well. So your x is going to be x itself whenever x takes between n plus 1 and your n. Now, in order to write this as in your piecewise form, let me take around 3 points. So let's say we'll take 0 to 1, 1 to 2, 2 to 3, right? When x is taking between 0 to 1, your n becomes 1. When x is taking between 0 to 1, your floor of x value is always going to be 0. But your identity function is not going to change. So it is going to be like x plus 0. And for the next piece, your floor of x function would be 1. So it would be x plus 1. And for your next piece, it is going to be x plus 2, so on and so forth. So we'll just draw these 3 pieces alone. Then we can, simply manipulate the graph for its entire domain. So the whole idea is the function. So the whole idea is we are basically having your identity function, and it is simply that your integers are getting added for each pieces. So let me just draw the identity function first. It's going to look something like this. Graph over here. So between 0 and 1, the function is going to be x itself. So I can draw the graph on your y is equal to x graph. But when it is between 1 to 2, what is happening exactly over here is it is x plus 1. So the entire graph gets shifted above by 1 units. So say that you are having 1 over here, and then 2 over here, and then 3 over here. The graph is going to be shifted upward by 1 units, such that your graph will start over here and then it ends over here. All right. So when it is between 2 to 3, this portion of the graph shifts by 2 units. So if it shifts by 2 units, you're going to have the graph over here. So when x is equal to 2, the function is 2. But if we shift it over 2 units, you're going to have it like at 4. So you'll have it over here. So this is the red lines are the function of x plus floor of x. So let me walk you through the graphing website. And this is your modulus function graph. And when I add these two functions, you'll be having a function like this, right? And when your y is equal to x graph gets added with a step function, which is your floor of x function, when you add these two, you'll be having a function to be like this. See, at 0, it is starting from 0. At 1, it is starting from 1. At 2, it is starting to draw graphs. So the whole idea is you'll basically have to find the function which needs to be written in piecewise form, and you'll have to adjust the other function into the domain which was already separated. And now we can add those two functions and we add the outputs in order to graph the function. So I hope you learned something new from this video. Please subscribe us for more such content. Thank you.